So the previous class we have studied about the preparation of preparation of alkynes. So in this class we have discussed about the properties of that compound. So in this talk we have properties of alkynes. First property we have the physical property, in which we can say that alkynes are first three alkynes, that means your ethyne, propyne and butane are gases. Are gases. Next, from C4 to C12, C4 to C11, carbon, they are all liquids, and above C11 are solids. Okay, higher alkynes are solid, in which all are colorless. They are all colorless and odorless. But your ethyne or acetylene have garlic smell. Okay, beta. For the second property, if we go for solubility, as they compounds are non-polar, these are non-polar, so does not dissolve in immiscible, does not dissolve in water. Dissolve in water. Okay, beta. But dissolve in organic solvents such as like carbon tetrachloride CCl4, benzene C6H6, ether, and all those organic solvents, they can be dissolved. Third property, melting point. And boiling point. Melting and boiling points are higher than alkenes and alkenes. आपके alkenes से और alkenes से क्या होते हैं? Higher होते हैं बेटा इसके. क्या? Boiling and melting point. Because they have a linear structure, as they have linear structure, as these have linear structure. due to linear structure की formation की वजह से they are more linear structure, due to which they are more closely packed. So their boiling point or melting point should be increased. Okay, beta. First is clear. They are having greater than alkenes and alkenes. Second point, when molecular mass increases, molecular mass of alkynes increases, melting and boiling point also increases. On increasing the molecular mass, increasing the number of carbon atoms, CH2 group, the melting and boiling point also increases. These are the properties of alkynes. These are physical properties of alkynes. Clear, beta? So next we have chemical properties. Next we have chemical properties. What is visible, na beta?
Yes, sir.
So chemical properties, first of all, they have at least one triple bond. They have a triple bond in them. So due to triple bond presence, they are reactive. They are reactive as we have the alkenes as they have double bond. They are reactive, so they are also reactive. First of all, when your alkyne or your terminal alkynes, first I saw about their acidic character. First we discuss about the acidic character of acidic character. Okay. First of all, the acidic character. When your acetylene or any terminal acid or terminal alkyne reacts with sodium or sodium amide, they can form beta what? In the presence of liquid ammonia, in both cases, liquid ammonia, they form here C triple bond sodium salt. They can prepare sodium salt. Na positive can this case. In case also it is had RC triple bond C Na positive. Okay, beta. And they can form sodium ethanide और सोडियम एल्केनाइड क्या बना सकते हैं लोग सोडियम एथेनाइड और सोडियम alkyne, but these cannot be prepared by the alkane and alkenes. So alkenes are not acidic, but alkynes are acidic in nature in comparison to both. Okay, due to the formation of these positive ions, they can be now react like acids. They have acidic character. They have now acidic character. Okay, they have the acidic character. Okay, they have a acidic character. But these are weaker acids in comparison to what? Okay, they are acidic in nature, but in comparison to water, they are less. How can we see that they are less than? As we react it with water, this product sodium ethanide with water. Water displaces the Na by forming the acetaldehyde. So HC triple bond here it will form HC triple bond CH plus में NaOH. Clear बेटा? So which indicate that your alkynes are weak acids than the water. Okay बेटा, clear? The reason behind that कि why this so, as we move along this course here, if C triple bond carbon, so this bond is easy to formation of the positive ion or negative ion. As in this compound we have Na positive, so due to formation of Na positive, this can be more electronegative compared to H. And when carbon becomes more electronegative, so the electrons sit toward the carbon, and carbon attracts the electrons, and there will be easy cleavage of that bond. So they are in now shows the acidic character. Okay बेटा, क्लियर व्हाट आई एम सेइंग? मैंने क्या कहा है कि जैसे आप देखोगे यहाँ पर कभी लीनियर स्ट्रक्चर होता है, और आप ये भी देख सकते हो इसमें जो एल्काइंस है, क्योंकि हाइब्रिडेशन अगर मैं देखूं तो इस पर हाइब्रिडेशन क्या है बेटा? sp3 क्या हाइब्रिडेशन है? इसकी हाइब्रिडेशन है sp, क्या है बेटा इनकी? sp हाइब्रिडेशन है। और जैसे जैसे कैरेक्टर बढ़ता है, s कैरेक्टर क्या होता है? इंक्रीज होता है। यहाँ पर x कैरेक्टर कितना बेटा? 50% s कैरेक्टर है। कितना परसेंट है? 50% एक्स्ट्रा कैरेक्टर होता है हमारे पास यहाँ पर। जैसे 50% क्या होगा? कैरेक्टर होगा, तो large s character the electron in the sp hybrid are held more tightly by the nucleus and quite electronegative. तो आपके जो इलेक्ट्रॉन्स होते हैं वो इस ऑर्बिटल्स में क्या होते हैं? बहुत ज्यादा न्यूक्लियस के पास होते हैं। जब इलेक्ट्रॉन न्यूक्लियस के पास ज्यादा होंगे तो क्या करेगा? दे मेक दैट इलेक्ट्रोनेगेटिव। क्या बना देगा? उसे इलेक्ट्रोनेगेटिव बना देगा। इलेक्ट्रोनेगेटिव बनने की वजह से ये हाइड्रोजन के बॉन्ड्स को अपनी तरफ अट्रैक्ट करेगा, और हाइड्रोजन को अट्रैक्ट करेगा तो क्या होगा? आपके ये जो बॉन्ड बना हुआ है आपके C और H के बीच में, क्या इसका कलर क्लीवेज हो जाएगा, यानी it can be break down easily and they form H positive ions, and when a substance form H positive ion it is behave like acid. Clear? Clear बेटा? So in that nature we can say this can be shown by the terminal positions only. This shown by the only terminal alkynes can show that. Terminal alkyne shows the properties of acidic behavior more than the your other one non-terminal alkyne. So for formation of that compound, we can simply say that when your butyne 1 ion react with silver nitrate, there is a test for separation. How can we distinguish between one terminal alkyne or the other one? How can we separate butyne or but2-ion? How will we distinguish them? How we will distinguish them? Okay, beta. So to distinguish these, we have start with the ammonical test. What is that? Ammonical test से हम लोग क्या कर सकते हैं? डिस्टिंग्विश कर सकते हैं आपके इसको बेटा, दो एल्काइंस को कि वो कौन सी एल्काइंस हैं, और एमोनिकल सॉल्यूशन ऑफ सिल्वर नाइट्रेट। ओके, एमोनिकल सिल्वर नाइट्रेट टेस्ट होता है यहाँ पर, सिल्वर नाइट्रेट टेस्ट भी बोलते हैं इसको। दूसरा क्या है इसका नाम? सिल्वर नाइट्रेट टेस्ट। क्या होता है देखिए इसमें, आप पहले अपना ये बनाइए CH3 CH2 C triple bond, this is your but 1 ion. Okay, this is your but 1 ion, or if we have CH3 C triple bond CH3, this is your but 2 YIN butyne। प्लस में अगर आप इसमें सोडियम, आपका सिल्वर नाइट्रेट टेस्ट अगर आप दोगे, क्या दोगे बेटा? सिल्वर नाइट्रेट का सॉल्यूशन Ag NH3 का होल ट्वाइस और OH ये आपका एमोनिकल सिल्वर नाइट्रेट टेस्ट है। क्या है बेटा? एमोनिकल सिल्वर नाइट्रेट टेस्ट। आप इसको जैसे रिएक्ट करोगे इट विल फॉर्म, क्या हो जाएगा बेटा? यहाँ पर H की क्या आ जाएगा? इट विल हैव द Ag नाउ, व्हाट विल रिप्लेस Ag? तो क्या होगा? CH3, ओके, इन CH3 वी हैव CH2, यहाँ पर आपका ये क्या बन जाएगा? आयन बन जाएगा, ठीक है, सिल्वर। तो यहाँ पर ये व्हाइट पीपीटी शो कर देगा। क्या शो कर देगा? व्हाइट पीपीटी, ओके। इट विल गिव व्हाइट पीपीटी। Why will this compound AgNH3 का whole twice ammonical plus OH, no reaction takes place, okay, no reaction takes place, so we can distinguish between alkyne one alkynes and the two alkynes. The presence of the bond in the first position and the second position can be distinguished by this method. Okay beta, clear? बेटा सिल्वर भी हो सकता है, क्यूप्रस भी हो सकता है। कौन सा हो सकता है? क्यूप्रस भी। इन द सेम वे क्यूप्रस आल्सो रिएक्ट विद द मॉलिक्यूल्स। कॉपर के साथ में ये क्या करेगा? आपका व्हाइट पीपीटी शो कर देंगे और आपके क्यूप्रस के साथ में रेड कलर शो करेगा। क्या शो करेगा? रेड कलर। क्लियर? तो आप इस तरीके से क्या कर सकते हो? उसे डिस्टिंग्विश कर सकते हो आपके कंपाउंड्स के साथ। This is the acidic character. Now about the addition reaction, as this is a triple bond, so it also gives the addition products also. So addition reaction is the topic. Next is addition reactions. Addition reactions. Addition reactions. Due to unsaturation nature, due to unsaturation यानी ट्रिपल बॉन्ड की प्रेजेंस की वजह से it can also show the what beta? Addition reaction. Okay. Nature as it has triple bond. I am writing the short triple bond here. It has the triple bond, so it can easily go for the addition reaction. For a addition reaction, it takes place in two parts. The first part, the attacking reagent is added to alkyne, and this triple bond changes to double bond. Now the double bond shifted towards the reagent, changes to the single bond. Okay, तो two steps में आपके पास होती है। सबसे पहले आपका सिंगल बॉन्ड क्या होगा बेटा? यहाँ से जो आपका ट्रिपल बॉन्ड है, should be break down to second. मान लीजिए आपके पास कोई X2 आपने क्या लिया? इलेक्ट्रोफाइल ऐड कराया। क्या कराया? इलेक्ट्रोफाइल। ओके, इलेक्ट्रोफाइल की वजह से क्या बनेगा? इट्स फर्स्ट चेंजेस टू योर डबल बॉन्ड। इसमें चेंज हो जाएगा बेटा, डबल बॉन्ड में चेंज हो जाएगा। देन अगेन दिस इज द फर्स्ट स्टेप, अगेन दिस रिएक्ट विद द X2 ग्रुप, योर एनी एडिशन ऑफ अल्काइल ग्रुप, अगेन X2 मान लीजिए इलेक्ट्रोफाइल दिया है। नाउ दिस चेंजेस टू योर व्हाट बेटा? सिंगल बॉन्ड। ओके, नाउ दिस चेंजेस टू single bond, and for your hydrogen groups or any compound can be addition. This is your addition product. So you will should know that here when there is addition they form the trans isomers. Mainly they form the trans isomers की formation होती है जब इसमें कोई भी X group क्या होता है? ऐड होता है। So first take the addition of halogens. Let's take the addition of halogen. So addition of halogen. Okay. We have the acetylene. Acetylene को हमने क्या किया? Clear test. Okay. Clear. And we introduce bromine Br2. सबसे पहले क्या होगा? इलेक्ट्रोफिलिक it gives a trans isomer. Okay. This will take place in the presence of CCl4 nature. We can say it is formed Br double bond C, Br and okay. This is your 1,2 dibromoethane. Okay, 1,2 dibromoethane. Again, Br2 in the presence of CCl4 carbon tetrachloride, it will form Br. This is your H. This is your H. This is your Br. This is your Br. What will form beta? 1, 1, 2, 2 tetra bromoethane. What will form beta? It forms 1, 1, 2, 2 tetra bromoethane. Board is visible now, beta. No doubt. But this reaction is also used as a test for unsaturation. Test for unsaturation. What will it form, beta? This is your bromine water. This is known as bromine water. What is it? Bromine water. Its color is red. What color is it should have? It had reddish color. Okay. It have reddish color. Then after the whether any substitute whether is double bond or a triple bond added to this compound bromine water, it changes to colorless. What form it up? Colorless. It forms colorless. उसका कैसे कलर रेड से वो क्या हो जाता है? Colorless हो जाता है, which indicate that there is a group, there may be a double bond or a triple bond in the compound. So any compound which is unsaturated can give bromine test. Okay, for the unsaturation. So in that case, we have to order reactivity order. If we find out the reactivity order of halogens to alkynes, reactivity of halogens towards your alkynes, the first more reactive is your chlorine, then your bromine, and then your iodine. As the iodine is added, iodine also only form the only the two alkene. So the addition of one molecule, it also form only they form only alkene. Okay, so addition of iodine towards alkynes is a slow reaction. If we add hydrogen now, addition of hydrogen. Now we can add also hydrogen as it is also there. So addition of hydrogen, if we done, we want to do so simply addition of hydrogen to take place in the presence of any catalyst. Okay. So addition of hydrogen. Addition of hydrogen या dihydrogen आप लिख सकते हो. In the presence of what? Any catalyst. Okay. Catalyst may be palladium, platinum, or nickel. So first of all, I tell you it takes place in the two steps. Suppose first is your H2 in the presence of platinum, palladium, or nickel. It will convert it into alkene first. Convert it into alkene. Then again H2. Any catalyst beta changes to ethane. So in that case, this is your ethane. What should be? It should be ethene. Okay, beta. Clear? You can add up CH3, CH triple bond CH plus S2. I write down the direct product. Okay, beta. The third one product I'm writing here. You take any of the catalyst, and the third one product should be CH3, CH2, CH3. Okay, the final product I'm telling you. CH3, CH2, CH3. That is your propane. Okay. From propane we get the propane by the addition of your dihydrogen. Okay. Now addition of halogen acids. Okay. Halogen acid. How will they carry a hydrogen acid? Halogen acid means HCl, HF, Br. किस तरीके से reaction आती है? What will be without this? When HCl reacts with this compound, what will have formed? Yes, beta. What will have? Now, when these compounds are react with hydrogen halides HCl, HBr, or HI, they form geminal dihalides. They form geminal dihalides. Okay, they form geminal halides. Okay, I will discuss this with you shortly. When your HCl react, geminal halides mean they form geminal. Like देखो बेटा क्या होता है. If you react that, use HC, this will be geminal dihalides. They will form geminal dihalides. They form geminal dihalides. So in geminal dihalides, what will they form? So your two halogen groups, when present on the same carbon, okay, when your halogens, when two halogens are on the same carbon atom, okay, when they are on the same carbon atom, they form geminal halides. What they form? Geminal halides. Okay, beta. Geminal means halogens on the same carbon atom. Halogens, two halogens. Okay, two halogens on the same carbon atom. They are known as geminal. क्या कहते हैं? They are called geminal. They form geminal dihalides. How this reaction proceed? If we go for further in the reaction, it will form first. देखिए किस तरीके से जाएगी बेटा मैं आपको बताता हूँ. First of all, this reaction start like this: CH, H, single bond, Cl, and your H here. Okay, when you add HCl, it will form this texture. Okay, we have a double bond here, so your H move to this side and Cl move to this side. Okay, now when this again we provide HCl, when again we provide HCl, this is your vinyl. This is your vinyl. Okay, this is your vinyl. This is your vinyl chloride. Vinyl chloride are those beta in which the halogen group or your alcohol, any group beta. This is your Cl. Okay, this is a functional group. When a functional group is present on the carbon-carbon double bond, carbon of the any carbon of double bond, then it is known as vinyl. What is known as vinyl? We discussed three things. Just read it up only. First, we discuss about vicinal halides beta. Vicinal word we have studied. We have now studied geminal, and third one we have now vinyl. The simple thing is that in vicinal we have group on the adjacent carbons. Okay, any functional group when present on the adjacent carbon atoms, then this is known as vicinal. When they are all present on the same carbon, okay, when they are present on the same carbon, then they are known as geminal. And when they are connected to any of the carbon which has the double bonded is known as vinyl. Okay, if any substance can react with like the allyl as we have, in which carbon double bond carbon and the other group goes to the carbon next to the, so when they have the sp2 hybridization connected to a hybridized as a vinyl, and if it's connected to sp3 hybridized carbon, that is known as allyl. So in that case, we can be halogens, we can have alcohols, we can have any group we can have. Okay, so clear. So in this test we introduce the HCl. First it forms this texture beta, it forms phenyl chloride, then it forms the geminal halides. Okay, so geminal dihalides होता है. क्या होते हैं? Geminal dihalides we have. Okay बेटा, clear? Okay beta, what will happen when we add to the unsymmetrical alkene? Alkyne, what will happen beta? If we take unsymmetrical alkyne, then your addition will be as the Marconi's rule. Okay, clear beta? Then your addition will be like Marconi's rule. Suppose we have now how will it form product? How will it form? Now it follows the Marconi's rule. Okay, तो Marconi's rule क्या कहता है कि negative part goes to that carbon that has less number of hydrogen. So first of all, you will clear CH3, CBr, double bond CH and this CH. Okay, this is your one again. When you put HBr, now again it has a less number of carbon. So CH3, CBr. This is your Br. This is your CH3. So in that case, we get the geminal also, but unsymmetrically we have the alkyne. Then the addition of water, halogen acids, or done on the basis of Marconi's rules. Okay, beta. Clear? We have to the Marconi's rule according to Marconi's rule. तो इस तरीके से आपको क्या करना है? एडिशन करना है Marconi's rule के अकॉर्डिंग. Then clear beta? The order can be first your HI can be edited. Okay, then the order of the HBr, then HCl, then lastly we have HF. So this is the reactivity order. This is your reactivity order. Okay. Beta, on Monday you have a test now, class 11.
Yes, sir.
So you have to come to school, okay?
Yeah.
Okay, beta. You have to come to school.
Yes, sir.
Okay, thanks, beta.